Hello everyone! In this video we are going to go over another example of Simulink applications. For this example we're going to consider a spring mass damper system with the following mechanical properties displayed in Table 1, which is on the next slide, and with the provided model, which we will show later. And for this example we're going to modify the model with the following four conditions. Here's the data table. So for the constants for our spring mass damper system, we are going to use a mass of 12, a damping constant of 53, and a stiffness constant of 96. We're also going to, for the initial model, have an initial displacement of 0.005 and an initial velocity of 0.001. Now, we are going to modify the model in order to create four different models. The first modification we're going to do is apply an initial displacement of 3 units. The second modification is going to be apply an initial velocity of 20 units. The third is going to be to apply a step input of 10 units. And the fourth modification is going to be to apply an impulse input of 10 units. And with that, let's go to Simulink. Now I have the Simulink model up. If you want to see how this model was made, you can refer to one of the previous videos, which was the video on Simulink applications, example 1. But for this video, the model is already created and we just have to modify it. So, the first thing we're going to do is we are going to run our original model so we can have our original data for comparison. And when we run it, we're going to open up the displacement window and we're going to take this and we're going to save this as a figure, which is right here as figure 1. And this is going to be a good figure to have as a point of reference as we continue to modify our data. Now, for the first modification, we are going to add a displacement of 3 units. So the first thing I'm going to do, we're going to get rid of the initial condition for the velocity. And change that back to 0. And then we're going to go into the second integrator block. This is where that position value was. And we're going to make it 3. And now if we rerun it, you'll see our new displacement is shown here. And just for comparison, if I pull up that figure 1, you can see here that the only thing that's changing in this model is the starting position, which is now at 3 instead of the 0.005. Now for the next model, which before we do that, I'm going to save this data as its own figure. For the next modification, we are going to add an initial velocity of 20. And we do that by clicking the first integrator block and adding 20. And then we're going to change our initial condition of 3 on the second integrator block to 0. And we're going to rerun it. And now, as you can see here, the initial position is not changing, but the amplitude is dramatically increasing. So we went from 0 all the way up to about 220 meters, give or take, for the first peak. Now, I'm going to save this as a figure, and I'll pull up the first figure here for comparison so you can see the major difference in amplitude between these two displacement functions. Now, for the next two, we're going to be modifying our inputs. So I'm going to change this back so the initial conditions are 0. And as you can see here, we have a sine wave. I'm going to leave the sine wave block here, but we're going to disconnect it, and we're going to add a step block. And we're going to connect this block, and we're going to click on our step block, and we're going to add a final value of 10, because that is our step condition. And we're going to run it. And as you can see here, if I click on the displacement, now you can see what a step of 10 does to our model. And in this case, it doesn't do a ton, but it does increase our amplitude so that our first peak is now 0.2. Now, to generate our impulse, we are going to use a pulse generator block. And we are going to change our amplitude to be a value of 10. And we're going to leave the other settings to their default. And now, when we run it, we're going to see our new set of data with those added pulses. And I'm going to save this as a figure as well. And now if I put all of the figures up, you will be able to see what each of our modifications did. Side by side. And that is all for this video. Thank you for watching.